the BW unit 4 we are taking. So already working principle, the torque equation, speed control, power stage diagram or losses are uploaded in one particular video. So in fourth unit, if you see the three-phase induction motor working principle, torque equation, condition for maximum torque, which is R2 is equal to X2. Along with that one, you might be asked a simple problems. So we have already taken the definition of the slip. So slip is the difference between the synchronous speed and the actual speed of the machine. If you find the video of the torque equation, there we have taken the slip in a complete manner. So now let us do the problems which are very formula substitution only. Let us take the first problem. A three-phase 20 horsepower 208 volt 60 hertz 6-pole star connected induction motor delivers 15 kilowatts at slip equal to 5%. Calculate synchronous speed, rotor speed, frequency. So induction motor, any problem, please enter the formula of synchronous speed. Synchronous speed ns is equal to 120 into f by p. Synchronous speed ns equal to 120 into f by p. 120 into frequency is given in the problem and number of poles is direct substitution. The speed of the rotor is n is equal to ns into 1 minus s. Speed of the rotor is n is equal to ns into 1 minus s. Directly the slip value is given. You can substitute, you will get the value. Next, frequency. So generally frequency is 50 hertz, but frequency under running condition, that is frequency of rotor is Fr is equal to S into F, slip times the frequency. So frequency voltage under running condition is S into frequency, direct substitution. So induction motor problems contain only the formula. Be ready with the formula ns equal 120 into F by P and rotor speed. S is equal to slip formula is what? Ns minus N by Ns into 100. Now, let us move to the second problem. A three-phase 460 volts, 100 hours power, mechanical power, this one, 60 hertz, 4-pole induction motor delivers output power at a slip. So this case slip power, determine the synchronous speed, motor speed, frequency, slip speed. Synchronous speed formula is what all the students, ns equal to 120 into f by p. So 120 into frequency is 60, poles you know, you directly substitute. Motor speed, actual speed n is equal to ns into 1 minus s. So ns is synchronous speed, 1 minus s, okay, and fr is equal to s into f. So slip speed is equal to s into ns, that is synchronous speed, s in slip times the synchronous speed. So the problems on induction motor are direct formula substitution, ns equal to 120 into f by p, slip and synchronous speed. So regarding this equivalent circuit, we'll see later on. So let me share the exact topics what we have planned. Now, so first, after the torque equation of three-phase induction motor, torque equation and working principle, you might be asked what are the different types of induction rotor. Induction motor has got stator, which is star connected three-phase winding. It also got the rotor. And once again, I'm mentioning this difference between these motors is out of syllabus, but you might be getting in the examination as we are targeting the fourth unit, right? So induction motor rotor is squirrel cage, which you have studied in the working principle. Squirrel cage means all the conductors are connected to each other. Okay. Now, another type of rotor is slip ring or wound rotor. That is, its induction motor slip ring rotor contains star connected winding. Now what are slip rings? Slip rings are mechanical devices, you can see here, which are used to connect any object to the rotating machine. As this slip ring rotor is rotating, I want to connect any bulb or I want to connect any object to this rotating machine. So slip rings are used to connect any object to the rotating machine. So slip rings are connected through the resistor. That's why here we are having the gap. So now you can draw this particular diagram. Here only the circular wheels, 1, 2, 3. What is the basic difference between squirrel cage and slip ring? Slip ring is used for high starting torque. That means in electric train, inside the lift, inside the electric train. Now what is the application of induction motor? Induction motor is used in electric trains, lift system, electric cars. So wherever we are having high energy requirement, we go for the slip ring induction motor. For fan blowers, hair dryers, we go for the squirrel cage. So 2 or 3 points you can remember here. Here squirrel cage. Squirrel cage is used for low starting torque and slip ring is used for high starting torque. Okay. Squirrel cage we cannot add any resistance, but slip ring we can add the resistance. That is a major difference. In slip ring induction motor we can add the resistance. Let me make this one short. We can add the resistance. Okay. Now it is used in cranes, elevators, it is used in water pumps. Okay. Squirrel cage has got high efficiency and slip ring is having low efficiency. So 3 points are sufficient for you to put in the examination. So we move to the maximum torque equation. So examination, if you see the word torque equation of induction motor or torque of induction motor, directly put on the torque expression what we have done. What is the torque equation of induction motor? T is equal to K S into E2 square R2 by R2 square plus S into X2 whole square. Differentiating this torque with respect to slip and equating to 0, you obtain S square equal to R2 square by X2 square, which is equal to S is equal to R2 by X2. So remember, maximum condition for torque equation, maximum torque equation means S is equal to R2 by X2. Condition for maximum efficiency of transformer we have seen, core loss is equal to copper loss. Okay. Now T is equal to K into S into E2 square R2 by R2 square plus SS2 square, which is equal to S equal to R2 by X2. This is the slip. Condition for maximum slip. So now next we move to the working principle of single phase induction motor. So last year this question was asked, not 3-phase, 4th unit working principles. We are having working principle of single phase induction motor. So many people are, if you study any other material also, I can challenge you. If you listen this one in an easy manner, you can go and try. Single phase induction motor. Where is single phase induction motor? Show me practically. Single phase induction motor is your washing machine. Single phase induction motor is your fan. Single phase induction motor is your mixie. Single phase induction motor, why the name induction? Because we are not using batteries. Okay, and power is transferred from stator to rotor purely inductively. Single phase induction motor contains stator, rotor, and relative motion between stator and rotor. You know what is relative motion? One object should be constant, another object should be rotating. Single phase induction motor contains stator, rotor, and relative motion between stator and rotor. The stator of single phase induction motor is stator winding, which is divided into main winding and starting winding. The stator of single phase induction motor is divided into starting winding and main winding. Always a capacitor is placed in series with the starting winding, whereas main winding and starting winding are perpendicular to each other. When input supply is applied to the stator windings, current I flows through the stator winding. This current is divided into I1 and I2. I1 current flows through the main winding, I2 current flows through the starting winding. These two currents create two magnetic fields, Phi1 and Phi2, which are perpendicular to each other. Due to the interaction of these two magnetic fields, Phi1 and Phi2, a rotating magnetic field is created. Rotating magnetic field moves or passes through the air gap between stator and reaches the rotor surface. The speed of rotating magnetic field is Ns is equal to 90 into F by P. 3-phase 120 into F by P, and it is single phase 90 into F by P. Rotating magnetic field cuts the rotor conductors. As a result, current flows through the rotor conductors, and hence rotor conductors create their own magnetic field, which is represented by phi c, rotor conductor magnetic field. Due to the interaction of both the magnetic fields, induction motor starts to rotate. So you can put this diagram, that's enough theory explanation. Single phase, I repeat once again, single phase induction motor contains stator, rotor, relative motion between stator and rotor. Stator is having main winding and starting winding, which are perpendicular to each other. When input supply is applied to the induction motor, current flows through the stator winding. This current is divided into I1 and I2. I1 flows through main winding, I2 flows through starting winding. As a result, magnetic fields phi1 and phi2 are created. These two magnetic fields are perpendicular to each other. Due to the interaction of these two magnetic fields, a rotating magnetic field is created. Rotating magnetic field cuts the rotor conductors. As a result, due to the interaction between rotor conductors magnetic field phi c and rotating magnetic field, single phase induction motor starts to rotate. Okay, rotating magnetic field rotates at a speed ns equal to 90 into f by p. So don't leave this one. So now I'm showing the animation. So definitely we'll get this one. Simple theory. Simple theory. This is a single phase induction motor. This is a pump. We can see single phase induction motor. Capacitor is used for starting purpose. It contains rotor, which is squirrel cage again. All rotor conductors are connected to each other. Stator winding, which is divided into main winding or starting winding. Another name is auxiliary winding. And these two windings are placed perpendicular to each other. So when electricity is applied, when input supply is given to the induction motor, single phase induction motor, current flows through the stator winding, which is divided into main winding and auxiliary winding. So two currents will be flowing. Those two currents create two magnetic fields. You can see these two magnetic fields interaction creates the rotating magnetic field. These are fluctuating, of course, first. Then the interaction between two magnetic fields create rotating magnetic field, which rotates the rotor. Due to the interaction of the rotor magnetic field phi c and rotating magnetic field, induction motor starts to rotate. And the speed is ns is equal to 90 into f by p. That's all. Up to this point only, you have to explain how the rotor starts to rotate. So they might ask you, along with this one, explain double field revolving theory. Double field revolving theory, which is exactly the single phase induction motor only. So there is one line assumption. In double field revolving theory, alternating magnetic field is assumed to be the combination of two rotating magnetic fields. One is two rotating magnetic fields which are moving in opposite direction. So I repeat once again, in double field revolving theory, alternating magnetic field is assumed to be the combination of two rotating magnetic fields phi f and phi b. One rotating magnetic field is moving in clockwise, another one is moving in anti-clockwise. So you have to give the notation. So as alternating magnetic field is the combination of two rotating magnetic fields, we can write here phi f is equal to phi naught equal to phi m by 2, because phi m by 2 is equal to phi m. This is what the simple assumption. Along with this single phase induction motor, we can put this particular explanation. Now next comes the question, generation of rotating magnetic field. How to explain the procedure to generate the rotating magnetic field. Rotating magnetic field is seen in single phase induction motor, three phase induction motor, synchronous generator also. What is rotating magnetic field? How to generate? Rotating magnetic field is generated when we are having three different windings which are displaced by angle 120 degrees. Rotating magnetic field is a vector combination of three different magnetic fields which are displaced by angle 120 degrees. Okay, this is the definition you can write. Next, you know, three magnetic fields which are displaced by angle 120 degrees means how we are supposed to write. You must write one extra line here. Phi r, phi y, phi b is equal to phi m sin omega t. Phi y is equal to phi m sin omega t minus 120. Phi b is equal to phi m sin omega t minus 240. In order to bring the relation average flux equal to 1.5 times the maximum flux, let us put omega t is equal to 0. When you put omega t is equal to 0, sin 0 is 0. And sin of minus 120, you get this value 0.866. Here it is plus 0.866. If you take the average of these three, The overall value is 1.5. So explain the generation of rotating magnetic field means the same explanation. Explain the working principle of induction motor and then follow by this particular simple equation. Now, torque slip characteristics of induction motor. So while you are, if you get this question, torque equation you have to write and you have to draw this graph. So what is this graph is explained, okay? So torque versus slip means you just draw a straight line, okay, starting from origin and draw one curved line. It is a linear operation, non-linear operation. Torque is directly proportional to the slip in this region from 0 to A, and from A to B, torque is inversely proportional to the slip. So what is this, how we get this expression? Torque equation of induction motor you have to remember. T is equal to S into E2 square R2 by R2 square plus S into X2 whole square. K is 3 mechanical constant value, this one. So remember torque equation of induction motor, T is equal to K S into E2 square R2 by R2 square plus S into X2 whole square. Okay. So from this expression, if you say case 1 assume that this resistance is very much less. Sorry, resistance is very much high. When resistance is very much high, torque is directly proportional to resistance. Torque is directly proportional to resistance. Then we get this particular straight line passing through origin. When reactance is very much high, reactance is present in denominator. So what's going to happen? Torque is inversely proportional to the reactance, case B. Then inverse relation, we say that we are going to obtain the rectangular hyperbola. So we should never operate the induction motor under this region. That's why it is called unstable. Induction motor must be operated only in this particular region. Okay. So this is slip is equal to 0, slip is equal to 1 under starting condition. You can remember. So maximum slip occurs at maximum torque point. Just draw this particular graph for the torque versus slip characteristics. We have done single phase induction motor, the problem, and next we are entering into the speed control. We have done power stages. Yes, this power stage diagram is important. Remember, P2 is to PC is to PS equal to 1 is to S is to 1 minus S. Means you have to explain the power stage diagram only. Slip definition we have seen in a clear-cut manner. Earlier video you can see. Now, one word is mentioned in the syllabus, starter. Okay, so we'll take that one. So what is the use of the starter? Let us say this is the motor and this is the supply to the motor. Directly we should not connect the supply to the motor. We must have the starter. Starter limits or reduces the starting current and passes the safe current to the motor. Starter limits or reduces the starting current and passes the safe current to the motor. So which starter? Explain any starter, any name they are giving, you can explain this one. Direct online starter. Usually I explain this one, but once again I am explaining DOL starter. Starter limits starting current. Now you see, starter is connected between supply and stator windings. If you see, this is the induction motor stator. Okay, starter where it is connected, this entire circuit is the starter. 3-phase supply, the fuse, relay, overload relay. Let me compress this one. Okay, no need to worry for this one. So when so what it contains? It contains a contactor and vertical studs, vertical rods. Okay, so under normal operation, normally closed switch, normally open switch. So how to start this induction motor? It is the working principle of the starter. So DOL starter contains normally open switch and normally closed switch. Under normal conditions, NO switch is open and NC switch is closed. In order to start the induction motor, NO switch is pressed mechanically. When NO switch is pressed, supply current flows from the supply to the stator windings. As a result, magnetic field is created across the magnetizing coil. I repeat once again. When normally open switch is pressed, magnetic field is created across the magnetic coil. This magnetic coil now attracts the contactor, which moves from left position to the right position. As a result, the supply terminals are connected to the stator. Now current flows through the stator winding. This is the explanation. That's enough. So starter is connected between the supply and the stator. Starter is used to turn on the induction motor. How we turn on? Directly we turn on the supply? No. Even if you turn on the supply, the starter button has to be turned on. DOL starter practically contains normally open switch and normally closed switch. In order to start the induction motor, normally open switch is pressed mechanically. As a result, current flows from the supply to the magnetizing coil. You can see the connection here. When normally open switch is closed, mechanically, current flows from the supply to the magnetizing coil. As a result, huge magnetic field is created. This magnetic field attracts the contactor, which is one iron rod. As the magnetic field is placed on the iron rod from left to right, as a result, the contacts get closed. That is, the contacts connects the supply to the stator. Now induction motor starts to rotate. In order to turn off the induction motor, normally closed switch is pressed. Or whenever overheating condition or overload condition is created, normally closed switch is pressed, it turns off. When normally closed switch is pressed, relays are going to disconnect the supply from the induction motor. That's all. The circuit and simple theory lines you can write. It is 100% theory. What are the problems will be asked, we have taken. That's it for this three-phase induction motor.